Assalamualaikum everyone. Yes student, I hope you are fine and doing well. I come up with another series of my lectures of mathematics of cryptography. Today we will discuss some classical ciphers like it may be depend upon substitution and as well as permutations. In classical cipher are mainly depend upon only either substitution or permutation. But right now the modern block ciphers are the combination of three component substitution, permutation and number of rounds. But today we will discuss some classical ciphers which are mainly based on substitution. It has only satisfied the characteristics of confusion, and if you separately apply the criteria of permutation as in ancient time of cryptology, I mean to say in 1949, before 1949, people are either using substitution or permutation separately to come up with crypto system. But after 1949, the master idea of Claude Shannon that give the idea how you can develop a modern block cipher with the help of confusion and as well as diffusion. I mean to say you can add up both substitution as well as permutation in a one block cipher in order to develop robust encryption mechanism that provide the confidentiality to your digital information. And the digital information, as I told you, everything that is in the form of binary bits is basically the digital information, and everything which is traveling and transmitting in digital medium are always in today are in the form of what you call bits. So your image is also in the form of bits, and because one pixel is consists of 8 bits, so it may be 3-channel image, or whenever I am saying 3-channel or 3-layer images, it means there is always a possibility of there will exist 3 matrices of m cross n of order rectangular matrices of I mean to say m by n matrices. Whenever I am saying this 3-channel, it means it is of 3 matrices of m cross n. And whenever I am saying it's a gray image, it means it has only one matrix, and it is only combination of all these 3 what you call layer, and you will get only one matrix. So today we are in the era of satellite communication as well. So mainly whenever we are seeing, we are sensing something with the help of satellite. So there is always a nothing. These images are not enough to give you the information from satellite. So there is always a concept of hyperspectral images. So hyperspectral images are also in the form of digital information. So from where you can sense the things from satellite. So how you can sensing flood, how you can sense your corpse through satellites. So there is no measurement from what you call in remotely. You can go there and measure all your corpse per unit area per. So you have to take satellite imagery, and with the help of the satellite imagery you can do this. So let me focus on my today lecture, which is related to classical ciphers. So let us develop. So since the course is mathematics of cryptography, so I have to develop the mathematics of classical ciphers. So classical system or ciphers, that is, some use substitutions and then some use. So in substitution, there are a number of substitution cipher, but I will discuss some all those which are quite familiar. So there are two types of classification, that is mono, alpha, vertical, ciphers, or poly. So इसमें ये होता है कि इसमें आपके पास cipher, affine, ठीक है। तो इसमें आपके पास हर एक प्लेन टेक्स्ट है, इसको इंडिविजुअली आप अप्लाई करते हैं हर एक के ऊपर शिफ्ट साइफर, और अफाइन साइफर भी मोनो, इसमें भी आप इंडिविजुअली अप्लाई करते हैं। लेकिन पोली अल्फ़ाबेटिकल में आप इंडिविजुअली बल्कि उसके चंक्स लेते हैं, चंक्स लेकर उसके ऊपर एज अ होल अप्लाई करते हैं। सो इन दैट केस इफ आई कैन से इन दिस cipher and it's different, that is based on square matrix, then it's based on rectangular, or then permutation, तो यहाँ पर हमारे पास इसकी काफ़ी टाइप्स के परमुटेशन साइफर हमारे पास अवेलेबल है, कॉलमनर है, रो साइफर है, बहुत ज़्यादा है, लेकिन मैं सारी की डिटेल में नहीं जाना चाहता। तो इसी तरीके से इसका एक और भी होता है मोनो अल्फा का पोली ग्राफिक साइफर, ठीक है, ये भी है। तो हम आज इसकी बात करेंगे इन साइफर्स की, मोनो अल्फ़ाबेटिकल साइफर्स की, हाउ यू कैन मेक इट टू बी ए क्रिप्टो सिस्टम। You keep one thing in your mind, that crypto system is consist of fundamentally 5 things. One, a space of plain text, space of cipher text, key, encryption function and decryption function. So let me start with shift cipher. So what basically, substitution. So what substitution give conceptually? Substitution give you confusion, and permutation give you this permutation fundamentally give you diffusion. And what is the idea of cloud channel? The idea of cloud channel is to merge these both in order to design and develop a good encryption mechanism that is consist of basically when we are saying confusion, it means to say changing value or overwriting the value, overwriting the value. And when I'm saying diffusion, it means to say just changing the position of given values. You just scramble the things. So if I can say in a football match, if you are saying left out, in hockey match, left out must be right and right must be left. So in that case, I'm saying cryptographically I'm permuting the two positions. The player which is playing at left out, I give instruction that you have to have play at right, and right one is have to have play at right. In that case, I just permute it and perform diffusion. And if I am saying player have to chain 10 number 10 shirt player have to have chain with the player which is seated outside the ground with 21. So I'm overwriting the player. In that case, I'm performing substitution. So same is the case with your crypto system. You have to have substitute as well as permute the thing. And what it did, basically, substitution just cryptographically just deform your any data into symmetrical distribution, like symmetrical distribution. But permutation will, if you perform permutation, then it basically uniform your data set. So in order to deceive your eavesdropper, so if your data set is uniform, so its entropy will be high. So in that case, if there is a symmetry, so the randomness is low, the the entropy will be quite low. But if your distribution is uniform, in that case you can say it's a very good encryption mechanism. So I will tell you later, but let me define the shift cipher. Whenever I am saying shifting something mathematically, what it means, you have to have add something in your fraction. It may be vertical upward, it may be vertical downward. So I am going to say the shift cipher is of encryption P is an encryption from D26 to D26 is of the form x, sorry, x plus. So I just start with some encryption as well as decryption functions. So if I can write it down like in terms of 5 tuples, as I told you, crypto system consists of 5 tuples. So the encryption function in that case is Z26 to Z26, and it is operate on some input that is from Z26 and x plus k mod 26. If I can generalize the idea, like it may be upon any n, okay, it may be operate on n, zn to zn. So I just generalize the idea like on n. So the decryption function is from again zn to zn. So the decryption function, if I can say the output of this is say y. So operate on y, it means y minus k mod of n. You will get back like x, and which is your plain text. This is plain text and this is cipher text. So if I can say the shift cipher consists of encryption, decryption, key. This is what we call the space of plain text, and this one is space of cipher text. So everything is consists of, according to crypto system, that set of space of plain text, space of cipher text, and then encryption as well as decryption function. And moreover, if you can see this composition of what you call decryption and encryption on x is equal to x, and the crypto system must satisfy this property, that is the composition of encryption or encryption is x. I mean to say the characteristics of identity function. So let us take example. I have 26 alphabets. So I must take a space of plain text is Z26, and space of cipher text is again Z26. So my encryption function is from Z26 to Z26, and key, which is K, it will be belong from Z26, and key should not be 0. It must be non-empty. It should not be 0. Otherwise, you will get just E of x is x identity function. Identity encryption. So I have to define the one-to-one correspondence between alphabets and modulo class Z26. So it is A, B, so this is one-to-one cross. A, B, C, D, E, F, G, H, I, J, K, A L M N O P Q R S T U V W X Y and Z. So I am defining the one-to-one correspondence, that is between 0, 1, 2, this is 3, 4, 5, 6, 7, 8, 9, and then I must define this one 10, 11, 12, 13, 14, that is 15, 16, 17, 18, then 19, 20, 21, 22, 23, 24 and 25. So I have defined the one-to-one correspondence, that alphabet is mapped on Z26. So I say A is 0 and 0 is A. So this is correspondence. So I take plain text as Ali, and my key is 3, which is belongs from Z26 and which is non-zero. So my encryption function is x plus 3 mod of 26. So A is 0, L is what? 11, I is 8. So I just pass all these plain text from my encryption function, that E of 0, 0 plus 3 is 3. So if you can see this one, like E of like 11, so 11 plus 3 is 13. So from here, 8 plus 3 is 11. So if you can see this one, if I can draw this with the one transformation, that your plain text is Ali. When you pass it through E, you will get what? And this is Ali, and if you pass it through encryption function, what you will get? 3 is correspond to D, and then 13 is corresponding to N, and 11 is correspond to N. So your readable message is converted to unreadable message with the help of this encryption function. I have to get back this D and L to Ali. So this is your what he called cipher text, and this is your plain text. So what I have to, so I have to get back this, so I have to apply decryption function, and I will get my plain text. So decryption function usually y minus k and mod 26. So y is basically these are output 3, 13 and 11. So just pass first output 3 minus 3 0, what you will get? A, and then D of what? 13 minus 3, what you will get? 10, which is L, and then D of what? 11 minus 3, which is 8, that correspond to I. So you will get back your plain text, which is Ali. So with the help of these one encryption function, decryption, as well as In mathematically, it's just say upward or downward, what you call left and right, vertical, sorry, horizontal stretching, scaling. If you add something or divide something, so you are transformed from on x-axis from left to right. So shift function is a mathematically it is nothing. It is just a shift from towards left to right. If I add, it means it is a left shift, vertical, horizontal left shift. If I subtract, it means I am tending towards right. So these are just shift cipher. So if you say this is just a shift cipher, let me advance this topic with the help of affine shift cipher. In affine shift cipher, we have further more requirement of inverse. So we have the inverse in the case of affine shift cipher. So if I develop the affine shift cipher affine shift cipher. So affine shift cipher, you know what affine is? Affine is a sort of function that where origin is not fixed. If I can say origin is not preserved, if I say y is equal to mx plus c, if you put 0, so m of 0 plus c, so y of 0 is c, origin is shifted to c. When you put 0, origin is shifted to c. If you can say this one y is equal to mx only, so origin is remain our origin here. 0, if you put 0, the 0 is preserved over with respect to this function, but with respect to this function the origin is not fixed. So whenever you put 0, so with the help of this function, the origin will be shifted from 0 to c by this function. So we call it as a affine function. So let me affine I must say affine cipher. Affine cipher is of the form ax plus b mod of n. I must say is a function from Zn to Vn. So it's a function from Zn to Zn. Should I use this red one?
Yes.
So decryption. So there is a condition over this A. So the with condition that GCD of A with n must be 1 and B should not be 0 and belongs to Zn. B should not be 0 and it must be belonging from Zn. Non-zero but belonging from Zn. You can take any possible values. There are n values. So you have what you call n minus 1 values you can take as a key. But the GCD of A with n must be 1. It means A must be belonging from unit element of Zn steric. Okay. So in that case we have to take only those elements to be A वो GCD with n must be 1, it means you have to take unit element. Otherwise, while you taking its inverse, there will be a fraction. So there is no fraction in modulo classes. So if I take a decryption function from Zn to Cn, so decryption function is what? If I can say this is y, if you can solve it, this 1 over a y minus b. So a is what? A inverse y minus b. I take this as to be a y. If I suppose this is y, so I have to solve it for x. So I place this b on left hand side. So you y minus b, and then place this a and divide it on both sides. You will get 1 over a, and ultimately you will say this as a decryption function. So here you can see we need inverse function. Inverse of A. So inverse is only possible in unit elements, where GCD with n is 1. So this is decryption function. So let me elaborate this with, I just take this same example and solving this with a fine cipher. I just take like unit element. Let us